Hello, my name is Josh Lewis. I am the team lead for the Formula FSAE Combustion Senior Design team. I'm going to give you a quick rundown of our project poster. As I stated, my name is Josh Lewis. The rest of the team members are Adam Koch, Josh Neff, Sydney Prince, and Sam Gringelshot. Here's a brief overview of our car and the goals we set out for the car. So overall, our requirements for the car were to comply to an FSAE 2022 rulebook. Design the car and manufacture a rolling chassis was our deliverable for Senior Design 1, but going into an SD2, we must complete the entire car and test it to prepare for our competition. The overall goals for the car were to create a good baseline for future teams. This is primarily because the FSAE team in the past has been really poor with documentation, so we wanted to set a good baseline and create a simple car to allow teams to build on for the future. With that, the overall car itself, we wanted to complete in complete competition, but finish top 50 as well. Corner through the skid pad dynamic event at 1.2 Gs, to create an aero kit with a CL over CD of -2.5, and overall finish the endurance event. Now we're going to look at the aerodynamics and the brakes portions of the car. So the aerodynamics, all the simulations were completed using Siemens Start CCM. The car ended up having a lift coefficient of -1.265 and a drag coefficient of 0.763. This ultimately created an aero balance of 54% front, but shot below our CL over CD goal, resulting in a -1.66. Looking at the brakes, we created a 55% front brake bias system. We're going to be using AP Racing master cylinders and Woodward calipers. However, we will be machining the brake discs in-house is the plan. Now looking at the chassis and the electronics progress. The chassis itself is going to be made out of space frame out of 4130 chromoly steel. The chassis was designed to triangulate to VD or vehicle dynamic sub-team points, and roughly based on the 2017 chassis, which was the last space frame of the team. We used the Motec M130 to run the engine. We were creating a custom wiring harness in-house and using the Motec PDM M15 for solid-state power distribution. For the powertrain, we chose a 510 KTM engine, primarily due to the abundance that we have of them at the Kawiki lab. We began dyno testing this engine to create a baseline engine tune, and we also are working on bench testing our new pneumatic shifting system. The suspension itself is going to be a push-pull rod system using a double A-arm. The uprights have been machined in-house, along with the control arms and the spherical cups are all being machined and manufactured in-house. Lastly, the FSAE team would like to thank all of our partners along with our mentors that have greatly guided us through this project.